Everyone, welcome to my poster presentation. The title of my poster is Privacy Encoder, Enforcing Privacy in Latent Space for Human Face Images. As we all know, with the development of devices equipped with camera, our society has witnessed a rapid increase in using and generating visual data. This data, especially facial images, have played a crucial role in developing advanced computer vision technologies such as facial recognition and detections, and so on. However, these images also contain a great mountain of sensitive information such as human identity. Directly share and use these images inadvertently pose a serious risk for privacy violation. So, to protect personal privacy in image dataset, we need to remove some privacy informations in images. But the currently common used privacy protection method in images such as mosquito, blur, are mainly of use case-based method. They are vulnerable in removing sensitive information and also hard to preserve in images utilities. Therefore, we need a novel facial image privacy protection method to achieve a balanced trade-off between privacy protection and utility preservation. According to the practical requirement, we think it should satisfy the following criteria, which is anonymization, realistic, usability, and configurable. To satisfy the above regulations, we design a learning-based framework to synchronize facial images privacy information in generate advanced networks latent space. The overview of our framework is illustrated in the methodology part. We can say it adapts an encoder and decoder network. The encoder consists of a feature pyramid network and privacy embedding layers. Feature pyramid network will first project the input images into high semantic and operable latent space as three different scales feature maps. Then, the privacy embedding layers will implement the identification manipulation on these feature maps to generate the privacy enforced latent codes. The decoder of our method implements a style guns generate network as the backbone, and it will use the generate latent codes from the encoders to synchronize the de-identified images. Our framework is trained to satisfy the above objective. We illustrate our training schemas in the right side of training part. We can see it adapt self-supervised learning and does not require any annotations. Besides, our decoders adapt a portrait generate network. So during the trainings, there are only encoders networks will be updated. To guide the training, we utilize a weight combined loss function, which consists of three dedicated loss for different objectives. We show it on the right side of training part. We can see that pixel level loss function and perceptual loss functions will used to enforce the reconstruction images to resemble with the original images. And the identity level loss functions is used to limit the amount of pivotal information present in the reconstructed images. We set privacy regulator betas to restrict the constant similarity between input and the reconstruction images identity features to reduce the privacy informations. To validate the effectiveness of our method, we implement qualitative and quantitative experiment. Quantitative evaluations between our method and different other methods are evaluated on the table. We can see a blur and muscat represent the traditional method, CI-AGAN and deep policy are the state-of-art learning-based method. MSE, SIM, and FID are metrics used to reflect the visual quality of different methods. DR is the detection ratios. It's used to represent the usability of policy projections of the utility preservation. As we can see in the tables, among these different metrics, our method achieved a very good performance. After that, we illustrate the quality comparison of the different policy regulation efforts. We can see in the pictures which below the table, with the lower regulators, the processed images identity significantly different with the original one. After that, we also show the quality comparison of different methods in the right side of experiment. As we can see that our method produced more realistic images, which significantly change the identity in the original images, but preserve the original images' other features. So, the experiment result demonstrates that our method can achieve a balanced trade-off between the image privacy, utility, and quality in real-world dataset. Okay, that's all my presentations. Thanks for your listening.